Hi everyone. Today we are going to talk about elements and compounds, and this goes along with Unit 1, Section 1 in your book. You want to title this Section 1, Elements and Compounds, and you can put notes. So let's start out just reviewing your investigation. Thinking about these things, these are definitions that you probably should have in your composition notebook somewhere during your investigation. So when we talk about decomposition, what we mean there is we mean that we are going to break down. So you can write in your notebook, decomposition is to break down. Electrolysis, electrolysis is going to use electricity to break down, because that means break down, a molecule into smaller parts. So when something decomposes, it breaks down into smaller parts. What we did is we took some water, H2O, we added some electricity, and we got H2O. Both of these were gases that were in the test tube. So what happened, think about what happened when we, first of all, when we look at water here, it's it can be a solid, it can be a liquid, it can be a gas. When you look at those physical properties of water that you started out with, it was clear. Some of you probably put it was wet. It took the shape of the beaker that it was in. And then when you wrote down the physical properties of these gases, you know, they were clear, they were hydrogen. This gas was probably flammable. You probably heard that popping sound. This oxygen gas. There was more hydrogen. You might have written that down. There was less oxygen, but when you put that flaming splint near the oxygen, it's reignited that flame. So, you know, you can make that inference that oxygen is needed to keep a flame going. And then one of the questions think about is which test tube had more gas and why? And when you look at, and this should have all been answered in your composition notebook already. When you look at this formula, H2O, that's our chemical formula for water. We'll talk about this number here, this subscript number here. There's two, that means there's two of that hydrogen gas. That's why there was more hydrogen gas than oxygen gas. All right, let me clear that and let's move on. All right, so we're going to start with matter. And any element, or an element, sorry, is any material that cannot be broken down into smaller parts. So when we look at the definition, when I'm underlining the stuff, you should be writing it down in your notebook, right? So by definition, elements, any material that cannot be broken down into smaller parts, right? We know these things by the periodic table. We see these elements on the periodic table. They are represented by a symbol. Okay, so we're not going to write hydrogen down. We're going to write H down. There's a specific way on how to write these. If it is one letter, so if the symbol is one letter, is one letter, it's hard to write with the mouse. I don't have my iPad back yet. You're just going to use a capital letter. So hydrogen is only one letter. It's H. It is number 1 on the periodic table. And you're just going to write H for hydrogen. If it is two letters, you're going to have the first letter is going to be capitalized and the second letter is going to be lowercase. So you're going to have first letter capitalized, second letter lowercase. This is not CI, this is CL. Okay, this is chlorine. What's chlorine? Chlorine, I don't know what chlorine is. I think it's 19. I could be wrong. Okay, so symbolized, one letter is going to be just capital, 2 letters, you're going to have capital and lowercase. Make sure you know that. You're going to be tested on that on your mastery check. Make sure you know all this, but. All right, so we said all these elements are located on the periodic table. Now, when we talk about matter, and we said that chemistry is the study of matter and how matter changes. By definition, matter is anything that has mass and takes up space. Now, there are 3 kinds, well, there's 4 states of matter. There's solid, liquid, and gas, and plasma. But we're only going to use those 3 states because plasma requires a huge amount of energy to disrupt the atom and produce ions. Plasma TVs, you've seen them, those are just excited electrons, right? So here's our periodic table. Oh, chlorine, I'm sorry, it's not 19, it's 17. There's chlorine. Let me do this, clear all my drawings. Just kind of, here's hydrogen, beryllium, gold. Notice if it's 1 letter, it's just capitalized. If it's 2, it's capital and lowercase. And there's neon. Okay. You need to know how to write these. You do not have to study the periodic table, but we'll talk about knowing the first 20. If you know those first 20 up to calcium, it makes your life really easy because you'll have to be writing chemical formulas, and it takes you a lot less time if you know those first 20s. We just use a lot of the first 20 elements. Not saying we don't use all the elements, but we mostly use those first 20. Okay. So compounds, molecules, and atoms. Let's talk about the difference between those. So a compound is going to occur when 2 or more different elements bond together. So we've got 2 or more different elements, like sodium chloride. Compounds are going to have different characteristics. So they're going to have different physical characteristics, they're going to have different chemical characteristics than the original elements that make them up. Think about your water. Your water was clear, it could take on a solid, a liquid, or a gas phase, or a state of matter. It was definitely, you can't light water on fire. But when you broke it apart into its original elements of hydrogen and oxygen, those were both of those were gases. Both of those should have been clear. And they were flammable, one was flammable and one kept a flame going. So really different than the compound itself. Now a molecule is 2 or more of the same or different elements combined. So water is a molecule. Water is H2. It has two of the same, and then it has oxygen. So anytime you see two of the same atoms or elements combined, even if it's with this different element, it's going to be considered a molecule. Like a compound like NaCl, and this is sodium. And this is chlorine, but we say chloride when we put it together. And we'll talk about naming later on. CHLOR. So sodium chloride is table salt. We find it delicious. By itself, sodium is highly reactive. It actually blows up in the presence of water. And chlorine is a gas that will kill you. It's what mustard gas is made out of. So again, thinking about these characteristics by themselves, this is a shiny metal. Very shiny. It's a soft metal. You can actually cut it with a knife. And when you put this in water, it explodes. And chlorine is a greenish gas. I believe it's green. It's a green gas. And it's toxic. It'll kill you. All right. A molecule keeps all the physical and chemical properties of the substance. So I just said water contains two hydrogen atoms, and so does hydrogen gas. It contains two hydrogen atoms. So an atom, we talk about an atom is the smallest part of an element. So you can have lots of, remember, elements can't be broken down into anything smaller, but they are made up of atoms. So atoms make up elements, elements make up compounds, and compounds make up everything around you. And go just look in your medicine cabinet, look in your refrigerator, look in your any cabinet, look on the back, you'll see chemicals everywhere. So there's a water molecule. This is an atom. We'll talk about this. It's made up of protons, neutrons, and electrons. It has a nucleus and it has an electron cloud. Click my drawings there. All right, chemical formulas. You got to know how to write these chemical formulas. Chemical formulas is going to show the symbol of the elements that are combined to make the compounds. So they show the symbols, and remember, symbols are how we're going to, it's a shorthand way of writing an element. I combine to make the compound. So I talked about NaCl before. When you don't see any numbers behind the symbols, so there's no number there, and there's no smaller number there. That means if there's no number, so when we write this, we've got our symbol. If there's no number here, that number, first of all, is called a subscript. There's no number, that we just represent that with 1. Okay, so there's no subscript there and no subscript there. That means that this combines in a 1-to-1 ratio. And you should know from math, when you see those semicolons, that is a ratio, 1 sodium to 1 chlorine. This is sulfuric acid. So you see now this one has these subscripts here. This sulfur doesn't have one, and then this oxygen has one. So this means you have 2 hydrogens, 1 sulfur because there's no number there. So we assume 1, and 4 oxygen. All right. SO, because they're so, both of, this is so, I just wrote so. All right, because they're both capitalized, that is sulfur, and that one's oxygen. Now, a lot of times this one will come up, CO. This is not, this is carbon. And this one's oxygen. Together, it's carbon monoxide. And again, we'll talk about naming compounds later. Do not confuse it with CO. Notice the difference. This is capitalized. This is lowercase. This is cobalt. Remember, anything I'm underlining or writing down, you should be writing down as well. All right, don't confuse those. Again, this number here, when we don't see one, this is a subscript. Okay. So I said the subscript, that's the small number behind the atom. So this is behind the atom. This would be in front of. And that's a different number. We call that the coefficient. This is behind. Okay. And then we have these things called diatomic atoms. All right. So diatomic formulas or diatomic atoms, these are atoms that cannot stand alone. They don't like to be by themselves. So you're either going to find them paired with another atom, or they are by themselves in pairs. So either you're going to, hydrogen's one, you'll never see H, it just won't be like this. Hydrogen's a diatomic atom, it won't be like that. It will either be like this, like HCl, which is hydrochloric acid, that's the acid we used, or it'll be like this. Right? So it's either going to be paired with something else, or if we just say hydrogen, if I just say hydrogen gas, and they're all going to be gases. Well, no, I'm sorry, that's a lie. Iodine's not, and bromine's not. They're going to be written like this. So if I just say hydrogen, it's written like this. If I say hydrochloric acid, it's written like that. If I say water, it's written like this. If I say oxygen, oxygen's another diatom. You're going to write it like this. Okay, so these are your diatomic atoms. There's 7 of them. There's hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. H is hydrogen, oxygen, N is nitrogen. I would write those down like I write N2. Nitrogen. because I could say, write the chemical formula for fluorine. So if I told you to write the chemical formula for fluorine, that's fluorine actually. Well, and E, you would put F squared. Well, F with 2, it should be F squared. I shouldn't say that because squares would be on top. So fluorine, chlorine, bromine, and iodine. So look at the periodic table, look how to spell those and write them like this. Okay, and this is how you write the formula. These are the formulas. That would be a chemical formula. This is a chemical formula. This is a chemical formula. This is not. This is just the element or the atom, we would say. This is just an element. That's not a chemical formula. Not a formula. Not a formula. All right, so we talked about writing chemical formulas. Then we also have chemical equations. Chemical equations is a written representation of the chemical reaction. So you had hydrogen and you decomposed, I'm sorry, you had water. And I can't do subscripts on this, so make sure you make that to lowercase or make it a subscript. And you decomposed it into hydrogen gas. So we'll just say hydrogen. Remember, hydrogen's your diatom, and oxygen. And remember, oxygen is a diatom, so you have to write it as O2. All right. This would be the chemical formula because we know that both of these, and we'd write this as a gas, and we write this as a gas, and this was actually a liquid. L. That's my chemical reaction. Both sides of this chemical reaction have to be equal. All right, so a lot of times think of this arrow as an equal sign. So here I have 2 hydrogens and I have 1 oxygen. Here I have, on this side, I have 2 hydrogens and I have 2 oxygens. Remember that oxygen's that diatom. It's got to come in pairs. So my hydrogens are equal, but my oxygens are not equal. When we write this chemical equations, the 2 sides, they do need to be equal. Oh, there's 2 sides to the equation. I read that wrong, but they do need to be equal. The reactant side is the reactants. These go on the left side of the arrow. So over here are your reactants. So I'm just going to put R for reactant. Those are on the left side of the arrow. That's what goes into the reaction. So what's going into the reaction is water. And then the products are on the right side. And the products are on the right side of the arrow. And that's what is made from the reaction. This one we said it's what goes in And then I also said, don't forget that both sides of these reactions, the numbers of atoms on each side must equal. So we'll talk about balancing that equation and how to do that. This is law. Making sure both sides are equal is called the conservation of mass or matter. But remember, all of these elements are made up of atoms. They're made up of matter. Anything that has mass or takes up space is matter. So this could be interchanged with mass or matter. Let me clear this out. All right. So please write this down. Whoops, let me go back. Please write this down. Okay. We've talked about the subscripts. And now I want to talk about these numbers coefficients. Okay. Subscripts go behind, they're the small number that go behind. These numbers can never change. You cannot change subscripts. You can always add coefficient numbers to balance both sides. So you are going to change these numbers to balance your equation. So when we first looked at this, I had just written it I wrote it the other way. I wrote it, which you can rewrite these. It depends on your reaction. This one is not a decomposition reaction. This one is a synthesis. You're making water here from those two things. But if we are at H2O, I had water. I added some energy. I'm going to put a little line there. And I got H2. I got hydrogen. And I got oxygen. And then I said there was hydrogen. I had 2 on this side. And I had 2 on this side. And I had oxygen. And I had 2 over here, but I only had 1 over there. See, there's no number there. So that's just 1. So what I can do is I can add coefficients. So how would I need to get 2 oxygen over here. I can put a 2 here because 2 times 1 is 2. So that number goes 2. But this is distributive. It distributes. So 2 times 2, because that number is 2, 2 times 2 is 4. So now I have 2 oxygens, so I'm good. I've got 2 oxygens on both sides. But now I have 4 hydrogens on my reactant side, and I only have 2 hydrogens on my product side. So again, I can change these coefficient numbers. So if I want to make this a 4, I'm going to have to, my reaction, because I had 2 water molecules, is now going to produce 2 hydrogen molecules. So it's going to produce 2 hydrogen. 2 times 2 is going to be 4. All right, that's the conservation of mass. We'll definitely go more into that in later class periods. All right, that was section 1.1 in your book. Now let's just see how you retain this or how you can synthesize this information. So you want to answer these questions in your composition notebook. What is the difference between an element and a compound? I might make a T-chart for that. One side write element, the other side write compound. If I asked you to compare and contrast, you could make a Venn diagram. Why do you think symbols are useful in describing chemical elements? So if I want to say hydrogen, why would it be useful to write a symbol? What are the symbols for these elements? So look in your look up a periodic table, carbon, copper, gold, helium. And then what information does the chemical formula of a compound provide? So give me all the information of that formula, H2O, H2SO4. What information does that give you? Copy this table into your book and fill in the blank areas. And then how are the properties of hydrogen and oxygen different from the properties of the compound H2O? So how are these different? H2O. How is that water different than the hydrogen gas and the oxygen gas? And then when we're talking about chemistry, chemistry is going to explain macroscopic, and anything that's macroscopic is what you can see with your eyes. All right, so we're going to explain macroscopic observations or phenomenons, like why did that happen? And then nanoscopic levels, these are at the atomic or the molecule level. It's you can't see nano, all right? And then we're going to use symbolic structures as a way to communicate. So we want to complete the chart below. I don't know why this didn't come up in your notebook. So in the macro, you can write macro and describe what you observed with the decomposition of water while generating hydrogen. It should be an oxygen. I'm not sure why it's not coming up. And then in nano, in words, describe what is happening to the compounds during the experiment of the electrolysis. So what happened to, remember, nano, you're doing on the molecules, what happened at a molecular level to water. And then your symbolic structure is you're going to draw a picture that represents the decomposition of water into hydrogen and oxygen. Beneath the picture, write the chemical formulas that are used to symbolically represent the elements. Okay, so you are doing, I should see in your composition notebook, the checking up, the chem to go part, and the essential question. All right, at any time, if you missed anything, go back, rewrite what you're missing. If you don't know the answers, you can always go back, re-listen to this, and ask me questions if you have any when I see you next. Great day.